NVIDIA's advantage in the AI and computing industry comes from cuda, the software platform that allows developers to fully use that hardware. cuda stands for Compute Unified Device Architecture. It is a programming framework created by NVIDIA that lets developers use GPUs for general-purpose computing, not just graphics. Before cuda, GPUs were mainly used for rendering images in games. With cuda, they became powerful tools for scientific computing, machine learning, and data processing. The reason cuda is so important is because hardware alone is not enough. A powerful chip does nothing unless developers can easily write code that runs efficiently on it. cuda solves this by providing tools, libraries, and a complete ecosystem that makes GPU computing practical. One of the key strengths of cuda is how deeply it is integrated into the software stack. It is not just a single tool. It includes compilers, debugging tools, optimized libraries, and frameworks that handle complex tasks like matrix operations, neural networks, and parallel processing. Developers do not have to build everything from scratch. They can rely on these pre-built components, which are already optimized for NVIDIA GPUs. Another important factor is maturity. cuda has been around since 2006. Over time, it has been refined, expanded, and adopted across industries. Universities teach it, researchers use it, and companies build their products around it. This long-term adoption creates a strong ecosystem that is difficult to replace. Performance is also a major reason why cuda stands out. NVIDIA designs its hardware and software together. This allows cuda to take full advantage of the GPU architecture. Memory usage, data movement, and parallel execution are all optimized in ways that generic software platforms cannot easily match. There is also a practical advantage for developers. Learning a new system takes time and effort. Once developers build applications using cuda, switching to another platform is not simple. Code would need to be rewritten, tested, and optimized again. This creates a form of lock-in, where companies continue using NVIDIA because the cost of switching is high. In the AI space, cuda plays an even bigger role. Popular frameworks like TensorFlow and PyTorch rely heavily on cuda for GPU acceleration. When researchers train large models, cuda is often the underlying layer that makes the computation possible. This means that even if another company builds competitive hardware, it still needs software support to match cuda's performance and usability. Another reason cuda is powerful is its ecosystem of libraries. NVIDIA provides highly optimized libraries for different use cases, such as deep learning, linear algebra, and data processing. These libraries are constantly updated to match new hardware improvements. As a result, developers get better performance without changing their code significantly. Competitors have tried to build alternatives. For example, AMD has ROCm, and there are open standards like OpenCL. However, these alternatives have struggled to match CUDA's level of support, documentation, and real-world adoption. The gap is not just technical, it is also about community, tools, and long-term reliability. In simple terms, cuda makes NVIDIA hardware usable, efficient, and widely adopted. Without it, GPUs would still be powerful, but far less accessible and practical for most developers. This is why cuda is often considered NVIDIA's biggest advantage. It is not just about having faster chips. It is about controlling the entire environment in which those chips are used. That combination of hardware and software is what gives NVIDIA its strong position in AI and high-performance computing.